Okay, this is where we left off last time. In the last program, what we did was we set each of the bits of the 8 bits to 1. Okay, this time we're going to just do a bit of modification. We're going to set each of those bits to 0. It's actually very easy. We just have to once complement that number we were printing. We're just going to do this, and we're going to have everywhere we had 1 to 0 this time. Okay, so let's just execute it and see how it is. As you see, you're seeing negative integers, right? So this basically happens because you once complemented all the 32 bits, so the most significant bit is 1, so it considers every one of those integers it's printing as negative integer. So let's see the unsigned equivalent of it. Okay, when you see the unsigned equivalent of it, you will understand it much better. Okay, so you're going to see huge numbers because almost the most significant 24 bits are 1. Okay, and even the rest of the remaining 8 bits, we're going to set each one of them 0, but most of it's 1. Okay, let me just show you to you through a scientific calculator what we are pretty much doing. Okay, all ones. Okay, and only 1 0 at the end. Okay, so that will be 1 2 3 4 5 6. One more. Okay, so this I'm going to convert it to decimal. As you see, only 1 bit to 0, the rest are all ones, right? So you see what it is, right? What are 429496729 That's the exact thing we're getting. So that's what happens. Okay, so with this we're sort of done with this program. We're going to look at more complicated programs coming next. As I had promised, we're going to look at a more complicated program here. So the question we're going to answer and the program we're going to look at here is, let's say you have a number C1. Okay, it's a 32-bit number, and I want n bits from position P. For example, 0x4321, this is the binary representation of it. Let's say I want from position 3, this is position 3 because this is position 0. Okay, I want from position 3 4 bits. Okay, I want this. Okay, or I want from position 11, that is this. Okay, 4 bits, these. So I put P equal to 11 and N equal to 4. So this is the question we're going to answer and look. So once I'm completed, you will understand how simple the solution is, but the kind of thinking that has to go in to produce that solution. Okay, so I want you to go ahead and play with bits because these are going to be really very important in a lot of your programs. Bit manipulation you really need to master. I'm going to look at 1 or 2 more programs about how you could exactly do bit manipulation. Okay, so let me say this. Now let me say I want this 4 digits. Okay, so how do I achieve it? First thing is, how I'm going to achieve it is this. First, I want these 4 bits or these n bits at the right hand side. So that means I'm going to right shift this to here. Okay, so let me just write it again and you will understand what I'm saying. The rest left side I'm going to fill it up with 8 zeros. So I'm going to fill these I have at the right hand side. Okay, now all I have to do is with AND it with n ones at this position. Okay, everything is 0 and I'm going to end it with n ones. See, what I'm really doing is breaking the problem into two pieces. One, the first piece, what we have to figure out is by how much we have to write shift C1 so that the n bits are at the rightmost side. Okay. The second problem is what we need to do to get n one bit at the right hand side. Two distinct problems which have got broken down. So let's just tackle the first problem. Okay, so what we are going to do to C1 to get these n bits or 4 bits to the rightmost side. Okay, from position P. Okay, now if I am going to right shift this right shift by P, where will we be? Okay, I'll show you where we'll be. We'll be here. So this will be the number, with whatever trailing zeros at the left side, and these many digits would have fallen off. Alright, but what we actually want is this. Right, so how do you achieve that? Very simple. We're going to right shift by P. Okay, we're going to right shift by P, we're going to achieve this. But if we're going to right shift by P plus 1, we're going to be here. The number ends here and these 4 would have trailed off. This n would have trailed off. So what I'm saying is, if we right shift by P plus 1, we would have n trailing bits which would have fallen off. How do we take it to the rightmost side? We'll left shift by n. So left shift by n is equivalent to right shifting by P plus 1 minus n. See, we have solved one part of the problem, right? Yes, we have solved one part of the problem. Now let's solve the next part of the problem. How do we get this bit sequence? Very easy, let me show you. Now let us get all ones. How do we get all ones? You take a 0 and ones complemented, you get all ones, right? So you take a 0 and ones complemented, you get all ones. Okay, now let's get zeros at the rightmost n bits. How do you do it? You left shift by n. N is the number of positions. Here it's 4, it can be anything. It can be 1, it can be 2, it can be 3. So here you get all zeros. Now, do you notice between these two binary representations, this is nothing but the ones complement of each other. So you ones complement this expression. Don't you see, it's absolutely easy, right? And you have to AND these two. So let me just put everything together. You will be amazed at the simplicity. So C1, I need to right shift by P plus 1 minus n. Okay, and I need to AND it with this. Okay, and I think I have this one. I need to print it, right? So let me print it. Printf. Let me print it as an integer. Let me add a new line, and I think I'm done. Let me add one more braces and a semicolon, and let me comment out the rest. Okay, I think I'm done. So this is the expression we have. Okay, So what I'm doing, I'm taking C1, I'm going to right shifting it by P plus 1 minus N, and I'm going to ANDing with this number. So how do I get this number? First I get all ones, okay, and I get this number by right shifting it by N, and then I ones complement to get this number. Absolutely easy. See, the solution is just one line. So all your programs that has to do with your bitwise operations are going to be this simple, but you need to think a lot to get this sort of an expression. I've just executed. You can see the output as 3, and that's exactly what we wanted. Okay, so from 11th position to 3 bits, 4 bits. Okay, so with this I'm done.